Hello, Algebra 2 students. This is Mr. Bear bringing you the lesson about completing the square. All right, so last class we saw that there are many ways to write the equation of a quadratic. So we've seen vertex form and we've also seen standard form, and we've talked about how we can graph them in each of those forms. The vertex form was really helpful because we could see the transformations that occurred. But how do we take a standard form equation and write it into vertex form so that we can see those transformations? Well, let's start by looking at these three graphs here, and I have three choices here for us to figure out which of these graphs goes with which choice. All right, so if we look at these equations, we can see that choice A is in standard form. So remember, standard form looks like y equals ax squared plus bx plus c. And what was nice about the standard form is that you could read off the y-intercept. Well, I guess I can't highlight it. I'll just circle it. So we can read off the y-intercept. That was one of the nice things here. And when I look at choice A, I see a y-intercept of 1. So when I look at my graphs, oh look, the middle one has a y-intercept of 1. So that means this must be graph A. The second one that we see here is in vertex form. So vertex form, if we remember, looks like y equals a, parentheses x minus h squared plus k, where the h and the k give us the vertex. Okay? So in this case, my vertex is 5, comma, there's an understood plus 0. So 5, 0 would have to be my vertex. And when I look at that, that is the third graph here. So that's graph B. So then by process of elimination, we would have graph C being the first one. Its y-intercept is 9, which, as you can see, if we were to extend this graph up, 6, 7, 8, 9, this graph would eventually cross at that point. Okay, what we're going to do today, though, is we're going to talk about how can we take these standard form equations and turn them into vertex form. Okay, all right, before we do that, let's see what all of these graphs have in common. All three of these graphs sit on the x-axis, which means that there must be only one factor that is working. So factor is something squared, meaning that it's the same factor times itself. Okay. And so we'll talk more about that process in a moment, but the question is going to be, how can I write these standard forms into something where I have a factor squared? So we're going to start off using a diagram. It says, Jamil used the diagram below to show that x plus 5 squared can be written as x squared plus 10x plus 25. Can you make sense of how this method works? Well, if we look here, we have to remember that x plus 5 squared means x plus 5 times x plus 5. And so when you multiply that out, x times x is x squared. That's represented by this big square here. Use a different color to illustrate the next part. Then we have x times 5, which we know is 5x. That's going to be these 5 rectangles here. And then we go to the next part, which is taking the 5 times the x. So that's going to be another 5x. That's going to be these rectangles. And then finally, we have 5 times 5, which is 25. And that's what all of these little ones are. There are 25 of them, 5 rows of 5. Okay, and so when we look at this shape right here is a perfect square. Its length and width are exactly the same, And so this is how we would visually think about a perfect square in algebra. So if I were to try this out on x squared plus, or x plus 4 squared, I know that I'm going to draw a big old square, and I know I'm going to have x plus 4. So what that means is, and then this will be x plus 4. So I'm going to go ahead and draw that. This is my x squared. These are my 4 individual x's. I guess I should have drawn them all the way down. And then over here I'm going to have 4 more sets of x's, and all of these are 1s. Okay, so the way I would get my answer here, I'm going to have x squared. I have 4 x's over here and 4 x's over here, so that gives me 8x. And then down here I have 16 individual squares. So I'd have y equals x squared plus 8x plus 16. And if I were to take the x plus 4 and just multiply it by itself and distribute out like I did over here, I would get the exact same result. Okay? But what I want you to be thinking about is this visual of completing a full square. Okay? All right, so let's look at example 5. We have y equals x squared plus 6x plus 9. I want to rearrange these to make a perfect square. So what I want to do is get all that so that I can make this perfect square. So I've got this big ol' x squared, so I know that's going to have to go in here. That's going to be this spot right there. I have 1, 2, 3, 4, 5, 6 x's. So when I think about that, I'm going to need 3 of them over here, and I'm going to need 3 of them over here. Oh, that looks terrible. Okay, so x, x, x. And then, of course, we can extend these down. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 little squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our perfect square. So now, what are the dimensions of this perfect square? Well, this is x plus 3, and this is x plus 3. How did you decide what the length of the square should be? Well, since I had 6 of these x's, I knew I needed 3 going across, and I needed 3 going down. So we need half of them to go across, and the other half to go down. Now when I look at this, this is just x plus 3 squared, so it's my vertex of the parabola. So notice now this is vertex form, so if this says plus 3, the x-coordinate of the vertex is negative 3. We had no leftover pieces outside of the square, so plus 0, that gives us the y-coordinate. So the vertex is negative 3, 0. All right, let's look at this next one. So now we're going to change things up. Can you use the diagram below to figure out what the vertex would be if this is our equation? Okay, so let's look here. That 6x, we use 3 of them across and 3 of them down because half of 6 is 3. So this is my 3 across, and this is my 3 down. So what we end up here is we have x plus 3 squared. And notice when we did that, that only gives us 9 of these little squares down here. And so we have 2 extra squares here, so we're going to have plus 2. So if I look at that, that means that this vertex, so if this says plus 3, we have negative 3, and then 2 is the other coordinate. That's going to be the vertex. Okay? If I look at the next one, if I look at this one, it says x squared plus 6x plus 5. So again, that's 6x, that middle term. I need half of them to go across and the other half to go down. So half of 6 is 3. And then we know that the x squared is just x plus x. Let me erase that. And so when we look at this, we know that we have the x plus 3 times x plus 3, so that'll be squared. But when you look here, we only have 5 of these little squares. We're missing 1, 2, 3, 4. So we're 4 less than the total perfect square. So minus 4. So now to figure out the vertex for this, what we're going to do, the opposite of 3 is negative 3. The y value is just the negative 4. So that's your vertex. Okay. All right, so this is kind of the visual way to help you understand how we're going to complete the square. So what you're going to notice is each time we looked at this b value here, and we ended up doing half of that. Now keep in mind I only did examples that didn't have an a term greater than 1. So what I'm going to do is show you how to do this without drawing all these diagrams, but rather we're going to look at the process for it. Okay? So if we look here, the first thing that we want to do is move the constant or c term to the other side of the equation. We do that just so that we can focus on just the part with the x's. Okay? If we have an a value that's not just 1 in front of the x squared, then we're going to factor out that a value from the terms with the x's. But then this third step is the key to completing the square. So that step is actually the true completing the square process. So we take half of whatever our b value is, and then we square it. And then we're going to add that value to both sides of the equation. If we had to factor an a value out, then we're going to multiply whatever we got in step 3 by that a value before we add it to the other side. Okay? Then we're going to factor the perfect square trinomial and then move the constant back over. All right, so watch how I do these examples, okay? So on the first one, I don't have an a value, so, well, I do, but it's 1. So we're not going to worry about that thing where you have to factor anything out. We are going to move this constant over to the other side. So that gives us y plus 20 equals x squared plus 8x. Now what I need to do is I need to find half of the b value. So half of 8 equals 4. And then I square that value. 4 squared gives me 16. So that 16, what I'm going to do is I'm going to add 16 to both sides of my equation. Okay, I'm doing it to both sides of the equation so I keep it balanced. So over here I now have y plus 36 equals, now this is x squared plus 8x plus 16. Half of the 8x is 4, so we're going to write that as x plus 4 squared. That's our completing the square. Think of it this way. The 4, when I double it, gives me the 8, and when I square it, gives me the 16. So then the last step is going to be to subtract this 36 from both sides, so we can get the y by itself again. And this is what we get. And from that, we can read off the vertex. So the vertex is going to be negative 4, negative 36. All right, let's try another example. So on this one, we're going to move this one over to the other side. So we get y minus 1 equals x squared minus 4x. Again, our x squared is just a 1 in front of it, so we do not have to factor anything out. So what we're going to do instead is we are going to complete the square. So we take this b term here, half of the b term, so half of -4 is -2. And then we have to take that -2 and square it, so we get a 4. So we're going to add 4 to both sides of our equation. Those can't, or wow, no they don't. Why did I do that? Sorry, y plus 3 equals, the purpose of doing the steps we did up here is to complete the square. So what was our half of -4? Well, it was -2. And when you square that -2, you still get this 4. So this is how it factors. So now we do our last step, which is going to be to subtract 3 on both sides of the equation. And we get y equals x minus 2 squared minus 3. And that gives us a vertex of, so take the opposite of that, and this value. There's our vertex. Okay? Let's try a couple examples where we have an a value that is different from 1. So if I do this, I'm still going to move the constant to the other side. I get y plus 5 equals 4x squared minus 24x. I want to now factor out that 4. So I'm going to factor out the 4. And I know you might be thinking, we can factor out 4x. I don't want to factor out the x right now. I don't want to factor it out at all, actually. Okay. And now what we're going to do is we're going to do our completing the square. So what's half of -6? That'll be -3. Take your -3 and square it, and you get +9. So I'm going to write +9 here. But I don't want to just write +9 here. I have to do 4 times 9, which is 36, because we factored out that 4. Okay. So that gives us y plus 41 equals 4 parentheses. And now I can write this part as a perfect square. Half of -6 was our -3. Squaring that gave me the 9. So now we have this. So then the last step is going to be subtract 41. And we get y equals 4 parentheses x minus 3 squared minus 41. And we can write the vertex of, so we use the opposite of that and the same as the -41. Okay. One more example, and then that'll be all I do in the video here. So this one, I need to move that 10 over to the other side. And I get y minus 10 equals 2x squared minus 28x. Now we are required to factor out that 2, so I'm going to have y minus 10 equals 2, parentheses, x squared minus 14x. And then we're going to complete our square, so we take half of the -14. Half of -14 is -7. And then we take that -7 and square it to get 49. So I added 49 here, but remember I have to add 2 times 49, which is 98. So y plus, let's see, -10 plus 98 is 88. Purpose of doing the completing the squares to write this as a perfect square factor. Half of the -14 was our -7, so that's what goes here. And we're almost home. Just subtract the 88 on both sides. And our vertex form is now 2 parentheses x minus 7 squared minus 88, which gives us a vertex of, what do you think it is? So use the opposite of the -7, and then the -88 is the other one. Okay? All right, that should do it. We'll do lots of practice in class, and hopefully if you have questions about this, you are reaching out to your teacher.